What is going on? This is Mr. Martin. We are on solution sets to equations with two variables. So I hope everybody is getting in line to graph some lines. If you haven't noticed already, for our objective, we are going to talk about two variable equations and we're going to do some stuff graphically. So that means we are on my favorite subject of all, graphing lines. Let's jump right into it. Okay, hopefully you began the warm-up on the notes. Up top, there's these two warm-up problems. They're going to kind of be helpful in some of the stuff that we're learning today. So go ahead, pause the video here. If you didn't try these, come back, see if you got the correct solution. All right, great to have you back. So hopefully you ended up with x equals 9. I went ahead and put that in set notation just so you can remember what it looks like. We should try and keep this one in the bag, right? Just in case if we're ever asked to do it. All right, example number 2, we were just plotting the points on the following graph. If you don't remember, try and recall our ordered pairs. These are x comma y. So we need to figure out how many to go left or right and then up or down. So this says 0, 3, so I stayed at 0, and then I have a positive 3. I went up to positive 3 and so on. So go ahead, check those dots. Make sure you have these all in the right place. All right, we got a good chunk of things to know in this section. There's a lot of good vocabulary in here, so at any point just pause the video. Make sure you get these written down. Okay. Before we did one variable, we had one solution. Now that we are in these two variable linear equations, we're going to have more than one solution, and we're actually going to have a infinite amount. Okay, not every combination will work, but we're going to have a infinite amount of combinations. Okay. Also, we have an ordered pair, also known as a point. Okay. When we have a solution set, we're going to have tons of solution sets, but each one that we list can be written as an ordered pair listed as x comma y. So please get in the habit of using that type of description in this section. All right, this is one thing to think about. Our x value, or even our x-axis, right? Just think, remember when we have these coordinate planes, okay, we have the x-axis, which is the left or right, the horizontal, and then we have the y-axis, which is our vertical. Okay, so any of these values found here on our x-axis, these are going to be our independent variables, and this has also been known as the input value. And then on the opposite end, we have our y values here on the y-axis. This is what we call the dependent variable. Let me go ahead and underline these. These are kind of important once we get into the modeling portion. Okay, and this is the output. We also have our standard form of an equation. Okay, this is some value x plus or minus some value y is equal to our constant. Remember, the constant, this is just a non-variable term. So we have an x term, a y term, and then a non-variable term. Here is our more famous form, which is slope-intercept form. And if you don't remember, the m is our slope, and the b is our y-intercept. Okay, this is very useful with graphing. Standard form is going to be useful with x and y intercepts, which are our next two pieces of information. So the x-intercept is the point where the graph crosses the x-axis, and the y-intercept is where it crosses the y-axis. All right, so taking a look here at this first example, okay, it wants to see if these ordered pairs are solutions to this equation. I'm going to go ahead and highlight this here, let you know that this is the equation that we're working with. If you look at it, we have the x and y term on one side with a non-variable term on the right. So that means we are in standard form already. Okay, we want to substitute the values and then evaluate and see if we get a true statement. So remember, as you see these things in your equation, make sure each part of that equation is there and only substitute the values for the variables listed. So we got this 4, and then we also should be substituting in parentheses. That way we can check for any kind of sign distribution. So we got this minus sign, then we have a positive 2, This is all equal to 10. So we got 4 times 3 is 12 minus 2 is equal to 10. And yes, indeed, 10 does equal 10. So yes, this first ordered pair is a solution. All right, go ahead and pause the video here. I'm going to work these out for you, but I want you to try them on your own real quick. Come back and see if you are matched up with what I got over here. All right, great work. So you should have got yes, no, yes, yes, and no. So we actually have 3 out of these 5 ordered pairs that are solutions to this equation. When we substitute them in appropriately, we get a true statement. All right, let's take a look at this graph here. It wants us to plot the points that were solutions on the coordinate plane. So looking back at those 3 out of 5, let's go ahead and graph these. Okay, so the first one that was a solution was 3, 2. So I'm going to graph that dot right here. Let's see, we also have 2, -2. And we also have 1, -6. Okay. So what kind of shape does this form? Well, it looks like they are rising up. They all look like they're kind of equally spaced apart. So I would go ahead and say that this is indeed a line. All right, so I'm just going to graph this line here. There is one thing I want you to consider. Oh, let me get that out of here. When you graph these lines, okay, it is very important that you plot the points needed to represent that you are actually identifying those correct solutions to that equation instead of just drawing a line. It's very helpful if you indicate these points. And the other part that is important is you should always draw your arrow tips on your lines. Remember, these arrow tips indicate that this line goes on forever. Okay, so here to the right, it wants you and a buddy to think of 2 other points. If you're watching this at home, just think about it yourself. What would be 2 other ordered pairs that would be a solution to this equation? Go ahead and pause the video here, come back. I'm going to tell you how I found them. All right, welcome back. So I got these 2 points, 4 and 6. So what I did, okay, is here, let me tell you. I went ahead and figured out how I got from one point on the graph to another point on the graph. So I took from this direction here, let me draw a line, and I counted these spaces going up, and then I counted the amount of spaces going to the right. So if I were to go up 4 and over 1, I would get to my next point. So from here I went up 4, which brought me to 6 for my y value. And then I went over to the 1, which brought me to 4. Okay. Additionally, you could have thought about it the other way and said, hey, I'm going to the right 1 and go from 4 to 5. And then you're also going up 4 and going from 6 to 10. Notice the shape that we make here when we think about our slope. Remember, the graph should create a straight line if it's a linear function. Or equation rather, and if you think about your slope, you should see some sort of box like this. You can go either way, and it would bring you in the same direction. Our second question asks how many ordered pairs are a solution to this equation. I said an infinite amount because any point that is on this line, this graph here, is an actual visual representation of every single solution to that equation from the previous example. All right, let's see what we got next. We have graphing a line using a table, okay? And then again here we have this equation, 2x minus y equals 4. What we want to do if we are using a table and we are just thinking about points that we can plot, we can do the same thing we did when we checked if those ordered pairs were solutions. But this time we're just going to choose the values ourselves and see if we can plot them. So one thing to think about, remember, your graph here that I gave to you only goes up to 8. So if you were to graph it on this graph, you want to make sure that your values you pick aren't that big. So the best value to always choose for substitution and solving is our good friend Mr. 0. Because remember, anything times 0 is a 0. And then I'm just going to go ahead and choose 1. 1 is a good multiplier, really easy. And then I'm going to choose some other low values here. So remember, your table might look a little bit different than mine, but at the end of the day, our graph should look the same. So we want to go ahead and substitute this in, and we will do that here. We got 2 times 0 minus y is equal to 4. We're going to have 0 minus y equals 4. Remember, if you got a negative, you need to turn that to a positive by distributing a negative throughout both sides. So we can divide both sides, right, by a -1, and we would get y is equal to -4. Okay, so let's go ahead and plug that in the table. Let's try our next one. We got 2 times 1 minus y equals 4. We're going to get this 2 here. We want to subtract that from both sides, so we got y is equal to, negative y is equal to 2. Let's divide that by -1. We get y is equal to -2. Alright, let's try the next one. 2 times 2 minus y equals 4. Negative y is equal to, 4 minus y is equal to 4. We're going to subtract the 4 from both sides. We get negative y equals 0. And this gives us y is equal to 0. Alright, the one thing I want you to think about is, do we see a pattern emerging here? It looks like we are adding 2, right, from one term, one value to the next. So we could assume that our pattern is going to go +2 and then +4. And we can do that without even doing all this extra math. There is something I will show in the calculator, and we will do that in the next lesson. So let's go ahead and plot these. We got 0, -4, 1, -2, 2, 0, and 3, 2, and 4, 4. Alright, so I will typically tell you how many dots I would like to see on your graph. This is a healthy amount. It actually matches the amount that we have on our table. So let's go ahead and draw our line. Please use a straight edge of some sort. Make it look as neat and identifiable as you can for these solutions. Alright, let's go to our next piece. We got the equation here, 2x plus y equals 4. Our instructions are saying we want to graph this line using slope-intercept form. And again, slope-intercept form is our best friend when graphing. So we learned how to rearrange formulas in 2.5. We are going to do that again here. This time we only have 2 variables. Okay, so we got 2x plus y is equal to 4. Remember, slope-intercept form is y equals mx plus b. So the variable in question that was solved for is y. And then we should stick to our form on the right. We have our x term, and then we have our y-intercept, which is just our constant. So let's go ahead and solve for y. It's already on the left like we got right here. Let's subtract this 2x from both sides. Okay, we can keep the y to the left. It's already here. That's where we want it to be. So these go away. We get y is equal to, here's the part to think about. If your x term goes first, we should be placing our x term first. Remember, these have signs. This is a +4. This is a -2x. It does not matter which order they go in. So I'm going to go ahead and put the -2x first. And then I got this +4. Now it looks matching to my slope-intercept form. The only other piece that I need to think about is when we graph, our slope is this coefficient in front of the x, right? We always want to think of this as a fraction. Okay, every slope is a fraction because it is actually our change in y over our change in x. Okay, delta y over delta x. This means the difference in y over the difference in x. And then the other way I like to think about it is our numerator, the value in the numerator, tells us how many to go up or down. The denominator tells us how many to go left or right. Okay, so we have this here. Let me box this up. Okay. Our y-intercept tells us we start at +4. So our first thing to do is we always put a dot on the y-axis of what our y-intercept tells us. Then we look at our slope and we start from the dot on our y-axis. It says -2/1, so it is telling me to go down 2 and to the right 1. Okay, and we can continue to follow this pattern, down 2, right 1. Okay, and we should put always, always, always as many dots as we can. Okay, now that we filled out the right side of our y-axis, we still can do some points on the left. Okay, so moving to the right, we went down and to the right. On the opposite end, we would want to do the reverse. So instead of down 2, we will go up 2. Instead of right 1, we will go left 1. So up 2 and left 1. All right, now I go ahead and draw my line. Let me fix that for you. I think that looks good. Maybe a little bit down here. Yeah. All right. Okay, so that looks good. This is all of our solutions. Graphing in slope intercept form is going to be very, very useful to us. Okay. So I have 2 examples here. I'm going to pause the video, let you guys try these ones on your own, and then have you come back, see what you got. All right, welcome back. So I went ahead and converted these to slope intercept form for you guys. I'm going to let you see how I graph them, just in case you need to see a little bit more of that. So this first one, we got a +3. So we put a dot here. Then I have a slope of -4/5. So always look at what your sign is. I have a negative. My slope should be going in a downward motion. So I'm going to go down 4 because I got -4 in the numerator, and then to the right 5, which is my value in the denominator. Okay. Can I go up 4? 1, 2, 3, 4. I cannot. So 2 points is the most that I could put on this graph. So I'm just going to keep it like that, and I'm going to draw my line. All right, the next one, I have also again another y-intercept of +3. So I put my dot there. Instead, I have a value of 3. Remember, this is 3/1. I'm not going to write it. We should get in the habit of always remembering that if we don't see a denominator, we always move 1 unit to the left or the right. So I'm going to go up 3, 1, 2, 3, and 1. I'm going to go down 3, 1, 2, 3, back 1, down 3, back 1, down 3, back 1. So if you look at the shape, it's positive. It matches what I have down here. So I draw my positive slope. All right, very good. Okay, the last piece that we are going to cover is the x and y intercepts. Okay, I put a little piece of information here to find the x-intercept. Set the y value equal to 0. To find the y-intercept, set your x value to 0. Okay, so the first thing that I always do, I mean, you can do it how you want, but I already know that I'm going to need to label my x-intercept, and I'm going to need to label my y-intercept. Okay, I know that these are going to be listed as ordered pairs, so I draw my ordered pairs. Okay. For my x-intercept, my y value is going to be 0, so I just put a 0. And then my y-intercept, my x value is going to be a 0, so I put my 0. Now I have everything set up for my solution. I just need to do my little bit of scratch work. So let's think about it. If I have an x-intercept that has a y value of 0, that means I'm plugging a 0 in right here. Okay, this is going in for the y. Anytime that I multiply something by 0, I get a 0, so it's almost as if I have completely removed this term. Okay, so the x-intercept, think of the equation without the y term. So I got 2x equals 6. Okay, I would want to solve that for x. Divide both sides by 2. I'm going to get x is equal to 3. Okay, on the flip side, for the y-intercept, we know the x value is going to be a 0. So it's like I'm basically removing that, and I now have 3y equals 6. So I divide both sides by 3, and I get y equals 2. Okay, so now that I have my 2 points, I got 3, 0, and I have 0, 2. I have my 2 points, and I can go ahead and graph my line. Easy as that. Hey, not bad, first try. All right, you go ahead and pause the video. Try the next one on your own. Let's see what you got. All right, fantastic work. This is what I got. I came out with 4, 0 and 0, -6. I went ahead and plotted those. Put that line up there for you. All right, so that is it. I want you guys to do as much practice with these graphing lines as you can, as we're going to jump into the systems of equations, which requires us to draw two lines. So in order to draw two lines, it's imperative that you know how to draw one line. I know you can do it. If you need some help, please reach out. Ask a parent, ask a friend, ask a family member. Most of all, ask Mr. Martin, ask another math teacher. There are plenty of people out there willing to help you graph lines because they are just so much fun to do. Thank you for tuning in again to Mr. Martin's Math Corner. I will catch you on the next lesson. Peace.